Hello everyone. In this session, I'm going to explain the program, assembly language program for reversing an array elements. Okay. Question is like this. Consider a situation where the price of 6 clothes have been stored in a contiguous memory locations from lowest to highest element, highest price. Okay. So we have in the memory location uh, prices of 6 clothes from lowest price to highest price, and these values are stored in a contiguous memory locations from lowest to highest. Okay. The program here is write an ARM assembly logic to store the prices from highest to lowest in the same memory location. So what you need to write is a program to to make the array elements instead of from lowest to highest, from highest to lowest in the same memory location. Okay. So it is nothing but we need to reverse an array elements. So whatever the memory location that we have, okay, so we need to reverse those values in that memory locations. Okay, it is nothing but you need to reverse an array elements. So say for example, this is the memory location that I have defined. Okay, and here I have initialized 6 variables. Okay, so these memory locations I need to store the values from lowest to highest, and I need to reverse them from highest to lowest. Okay, so in this memory location only. Okay, so this is the program what we have. So how to code this? So initially what I have done, uh, since I have taken as 6 close, so I'm initializing the variables 6 in order to maintain the counter. Okay, I have used 3 resistor. I think I have used 3 loops. Okay, so that's the reason I have used 3 resistors which holds the counter. So if the question is asked for 10 close, then you should mention this as a 10. Okay, and initially I'm making the point R3 resistor point to the initial address. Okay, so this is what the address I have defined. This is the where the memory location is defined. Okay, so I'm storing the initial value into this resistor. So R3 contains the address of first memory location. Okay, that's why I'm loading it. And then I'm using R9. So R9 register. So initially I need to store the 6 values, right? So that's why I have used R9 register. So initially I initialized as 1, then I will increment by 1. Okay, so this is the initialization of the memory. Okay, whatever that memory we have defined. Okay, so let's see. uh, I'm using a label init, so that I will come back once again in order to store the values of 6 clothes. Okay. First, store R9, comma R3, comma #4. Oh, so what is it? So I'm going to store the value content of R9 in the memory location pointed by R3. So which is nothing but in the reverse memory location. And then I'm going to increment the value so that it will point to the next memory address. Okay, so since the value that we are storing is a 32-bit value, so that's why I incremented by 4. Okay, yeah, now I have initialized one memory location, so that's why I'm going to reduce this R7 by 1. So my I have initialized to 6, so that I need to store 6 values. So once I store the one value, I'm going to reduce the number of iterations. That is, now it would be 5. And again I need to increase the mm, value of R9 by 1, because the question is asked from lowest to highest. So that's why I'm incrementing the value by 1, and I'm checking whether I have reached the iterations. That is, compare R7 comma with 0. No, after first iteration R7 will be 5, right? Then if not equal to, again I will go back to the initial label. So again, I will store the second variable in the second memory location pointed by R3. Okay. Again, I will increment to point to the next memory location. Again, I will check whether I will reduce the counter value by 1. Okay. And again, I will increment the resistor R9 value. Okay. So with like this, I will continue up to 6 elements. So once I store the 6 values into this memory location pointed by rev. Okay, so once I initialize all these values, I will stop. So now I'll come to this instructions. Okay, what are these instructions? So what logic I have used is, I'm taking the values from this memory location. Okay, I have initialized the values in this in init values. Okay, so when I will read this memory location value, and I'm going to push into the stack. Okay, so as you know that the stack is nothing but first in last out, right? So I'm going to push all the elements into the stack. Okay, and so this is the code for pushing of values into the stack. Once I push, then I need to pop the elements. So when I pop whichever the element that I entered last, so that is the first element that I'm going to get. Okay, so once I get the first element, I'm going to initialize that into the first memory location of this particular variable. So this is the logic I have used for reversing the content of array. Okay, so that's what you can see here. First I'm going to load the register from this memory location. So what is this memory location? It is nothing but whatever we have initialized, right? So now reverse. So r1 will be pointing to the first memory location. I'm going to store what the content into the register r2. Okay, and then you can see this is the push operation I'm doing with the stack. Okay, as you know, r13 will be pointing to the stack pointer, right? I'm going to push the whatever the content of register r2 to the stack, right? And then I'm going to increment the r13 address pointer value so that it will point to the next position. So this I will do until what? Until the r5 becomes until r5 becomes 0. So why r5 becomes 0? Because I have 6 elements. That's why I initialize. So once I push all the elements, so I will end with this loop. Okay, so once I end, what I have to do, I have to pop, right? So this is the code for popping out the elements from the stack. So whatever the element that I'm going to pop, I'm going to put that into the first memory location, then second, then third. Okay, so on. So you can see that this is the code for popping of the element from the stack. Okay, so I'm going to store that value into the r4 register. So this content of r4 register I'm going to put into this memory location pointed by r3. So you know r3 is pointed to the first address. So first whatever the element I will pop, I will put into the first memory location, then I will increment by 4. So like this I will continue until I pop all the values from the stack. So once I done this, so I will check whether whatever the elements which are stored in this memory location are from highest to lowest. You can see that the value that I am storing into loading into the register R5. So you can verify whether I am getting the correct value or not. Okay, so just I will show the demo. Errors. Yeah. So initially I'm going to store R5 6, R6 6, R7 6. Then I'm going to load the starting address into the register R3. So this is the starting address, and I'm going to store the R9 with a 1. Okay. Now I'm going to initialize the memory location pointed by R3. What value I'm storing? I'm storing 1. Okay. Yeah, 1 is initialized. Now you can see that the address is pointing to the next memory location. So in the next memory location I'm pointing what value? I'm decrementing r7 here. So why I'm decrementing? So that to keep count how many elements I need to initialize. So I need to initialize 6 values. So 1 I initialize, so that's why r7 is now 5. Okay, now you can see the next value that I'm storing is 2. Okay, yeah, so this will continue until what? Until the r7 becomes 0. So you can see that until, yeah, now we can see that r7 is a 0. Okay, now I will compare r7 comma 0. So since it is equal, it will not go back to the initialize. Okay, again I'm storing the r1 in the r1 register. I'm going to load the address of reverse. Okay, yeah, you can see that r1 is pointed to the base address. Now what I'm doing, i'm uh, I'm pushing into the stack, right? So what I'm pushing, so whatever the content of resistor R2. So what is the content of R2? So it is pointed by R1. So R1, the whatever we have initialized. So the first value I'm going to store into the R2, and then I'm pushing into the stack. Okay, so what is the first location value? 1, right? So this I'm pushing into the stack, right? Yeah, so this will continue until what? Until R5 becomes 0. You can see here, first I have pushed 1, next I will push 2, next 3, next 4, next 5, next 6. So overall we have pushed. So this is the stack, right? Stack. So initially I have pushed 1, then 2, 3, 4, 5, 6. So these are all the elements that I have pushed. So my stack pointer will be pointing to here, right? So now what I will do, I will pop from this stack. So initially I will pop, so the last element that I have pushed is 6. Okay, so this will going, I'm going to pop. That's what I'm doing here, next operation. Okay, so now you can see that R5 is equal to 0, so it will not execute. Again I'm storing the R3 to the base address. Okay, base address. Now you can see it is pointing to base address. Now what I will do, I will pop the element. So whenever I pop this, R4 contains the top of the stack. So what is the top of the stack? Top of the stack is 6. So 6, what I'm doing, I'm going to store that into a memory location pointed by R3. So R3 is pointing to the base address. So initially I'm going to store this R4 value to this base address. So what is the content of R4? It should be 6, correct? Because it is the top element in the stack. So this is the element. So now after removing this, my pointer will be pointing to 5, correct? So next you can see that I'm going to push, I'm going to store 6. Again I will increment the memory location. So now again I will compare R6 whether it is 0, no. So again it will continue. So next, what is the top element? Top element is 5, right? This is the 5. Now I will store that into the second memory location. Okay, next, yeah, next value will be 4, next 3, next 2, next 1, right? So once I do for all the elements, so all the elements are put into the memory location. So I need to verify whether the correct values are there or not, from lowest to, sorry, from highest to lowest. So just check that. So for that time I have used this loop too. Okay, so so you can see in the content of R5, right? So I'm loading the, in the register R3 I'm going to store the base address. I'm going to check what is the content of R3 by loading value into the register R5. You can see the first value will be 6. You can see it is 6. So next value will be 5, then 4, 3, 2, 1. So we have reversed the value of the array successfully. Okay, so this is the code. You can do it in many ways. So one of the way is what I explained. Okay, thank you.